Good morning, sir. This is Ashwita from Computer Science and Engineering Department. I am here to give my presentation regarding CAA to assignment. The topic of my presentation is breadth first search algorithm with example. Outline of my presentation: Introduction to breadth first search algorithm, key concepts of BFS, understanding the breadth first search algorithm, example, working principle, time complexity of BFS, applications of BFS, limitations of BFS, and conclusion. Introduction to breadth first search algorithm. Breadth first search is a graph traversal algorithm that explores all nodes at the current depth before moving on to the nodes at the next depth. BFS is often used to find the shortest path in an unweighted graph. It operates by visiting all neighbors of a node before moving on to the next level. Key concepts of BFS. BFS uses a queue data structure to keep track of nodes to visit. The algorithm starts by visiting the root node and then explores all the neighbor nodes before moving on to the next level. BFS ensures that all nodes at a given depth are visited before moving on to the next depth. Before we move further and understand breadth first search with an example, let's get familiar with two important terms related to graph traversal, that is, visiting and exploring. Visiting a node. Just like the name suggests, visiting a node means to visit or select a node. Exploring a node means exploring the adjacent node's root, child root of selected node. Understanding the breadth first search algorithm. Breadth first search algorithm follows a simple level based approach to solve a problem. Consider the below binary tree, which is a graph. Our aim is to traverse the graph by using the breadth first search algorithm. Before we get started, you must be familiar with the main data structure involved in breadth first search algorithm. A queue is an abstract data structure that follows the first in first out methodology. Data inserted first will be accessed first. It is open on both ends, where one end is always used to insert data in queue and the other end is used to remove data, that is dequeue. Now let's take a look at the steps involved in traversing a graph by using breadth first search. Step 1. Take an empty queue. Step 2. Select a starting node, visiting a node, and insert it into the queue. Step 3. Provided that the queue is not empty, extract the node from the queue and insert its child nodes into the queue. Step 4. Print the extracted node. This is the enqueue that is used to insert data, and dequeue operation is used to remove the data. Example. Take a look at the below graph. We will use the breadth first search algorithm to traverse through the graph. In our case, we will assign node IA as the root node and start traversing downward and follow the steps mentioned above. First, first we will insert a root node, that is A. Then if we print A, then the print and A will be printed and insert the child nodes B and C are inserted into the queue. Next, after printing the B, the child nodes of B will be inserted, that is D and E. Next step, if we print C, the child nodes of C will be inserted into the queue, that is F, G. Then after printing D, the child nodes of the D will be entered into the queue. But here the D does not have child nodes, so then no elements will be entered. Then again we print E, then F and then G. Like this we will print the queue elements. The above image depicts the end-to-end process of breadth first search algorithm. Working principle. Assign A as the root node and insert it into the queue. Extract node A from the queue and insert the child nodes of A, that is B and C. Print a node A. The queue is not empty and has a node B and C. Since B is the first node in the queue, let's extract it and insert the child nodes of B, that is node D and E. Repeat these steps until the queue gets empty. Note that the nodes that are already visited should not be added to the queue again. Time complexity of BFS. The time complexity of BFS is big, big O of V plus E, where V is the number of vertices and E is the number of edges. In the worst case scenario, BFS visits every vertex and edge in a graph. BFS is efficient for finding the shortest path in an unweighted graph. Applications of BFS. BFS is commonly used in message solving algorithms to find the shortest path from the start to the end. It is also used in network traversal algorithms to discover connected components in a graph. BFS can be employed in social network analysis to find the degrees of separation between individuals. Limitations of BFS. BFS may consume a large amount of memory, especially in graphs with a high branching factor. It is not suitable for graphs with weighted edges as it does not consider edge weights in its traversal. BFS may not be efficient for every large graphs with many nodes and edges. Conclusion. Breadth first search is a fundamental graph traversal algorithm that explores nodes level by level. It is efficient for finding the shortest path in an unweighted graph and has applications in various fields. Understanding the key concepts and implementation of BFS is essential for solving graph related problems effectively. Thank you, sir. This is presented by M. Ashwita from Computer Science and Engineering Department.